Hello guys, Oscar Hotel 8 Sierra Tango November Julian here for Off-Grid Ham Radio. Today we're talking about battery management, but it's a little bit different than the last video. This time we're talking about a Bluetooth-enabled lithium iron phosphate battery, which has a built-in shunt that we can access over... Wait, I'm just rambling. Let's call this the ultimate Ham Radio battery pack. Alright guys. For an Android or iOS app. If you're a ham radio operator, overlander, RVer, or anyone else who's trying to reduce the wire mess, you're going to want to see this. Stick with me, and I'll tell you all about it. Alright guys, let's go.
You are listening to the Emergency Broadcast Systems. This station broadcasts emergency news and official information on the air for assigned area.
So, we have two of these Bluetooth-enabled batteries. One is 12.8 volts, 100 amp hour. The other, 25.6 volts, 100 amp hour. Both are Bluetooth-enabled with internal shunts and battery management systems. They both come from Power Queen, who was kind enough to send them over for testing. The one we're interested in for Off-Grid Ham Radio is this 12.8 volt, 100 amp hour model. Let's take a quick look at the specs. This is a 12.8 volt nominal voltage lithium iron phosphate battery. It's rated for 100 amp hours or 1280 watt hours. And it has a max continuous output power of 1280 watts. In some respects, it's very similar to the 100 amp hour lithium iron phosphate batteries we use in the off-grid ham shack, but there are some differences. Two of those differences are the Bluetooth BMS and the shunt, allowing us to monitor wirelessly the incoming and outgoing current, as well as the current state of charge of the battery. Okay, before we do anything else, we need to set the battery up for operation. That's a pretty simple process, but we'll walk you through it step by step. The very first thing we want to do is find these things in a small plastic bag that comes with the battery. We've got the caps, the lug caps, we've got the lugs themselves, and we've got a couple of washers. Now, in addition to those lugs, washers, and caps we have here, we're also going to need a multimeter for testing. If you haven't done so already, go ahead and make your pigtail. I'm using one side with ring connectors, and the other side with Anderson power pole. Now normally my pigtail would be of a much heavier gauge of wire. However, I'm going to use this for ham radio, for a QRP radio and a laptop and perhaps a few lights. And that's about it. So it's not going to draw much amperage at all, maybe 10 amps or 15 amps at the absolute most. So I'm using this lightweight 10 gauge wire. And I'm not going to do it for this test, but we should also wire a fuse, at least on the positive side. You can wire them on both positive and negative between your battery and your pigtail. We're going to leave this out for this testing so that we can streamline this video. Now, the first thing we do is remove these cap covers. There's one for the negative, and there's one for the positive. Put those aside. All right, for those of you who like to skip ahead, you should take your multimeter. You've probably done this already and are freaking out about the voltage you saw on the battery. So you removed those safety caps. Now you can use your multimeter to test the voltage. What you'll find is that your voltage is around 3 to 3.3 volts. This is a standby mode that Power Queen uses to ship the batteries. It's a low voltage mode, like a hibernate or a sleep mode, that allows them to ship the batteries safely. This is perfectly normal, so no freaking out about it, okay? So what we're going to do now is take a washer. We're going to take our pigtail. And we want the positive pigtail. We're going to do positive first. put one washer under our ring terminal. One washer under our ring terminal, and put our screw in. And just go ahead and screw that in. We don't have to tighten it down totally now. We just want to make sure that it can't come off. Now we'll do the same thing for the negative side ring terminal. We'll take our washer, put one on the bottom. We'll take our lug, put that on the top. Okay, and we'll screw that down as well. Whoops, I've made a mistake. And we'll screw that down as well. Now you'll see that you actually have markers on the battery that tell you which one is positive and negative, so that if you're colorblind, for example, you can still see which one is which. I'll show you the other side. Sorry if you couldn't see it. Anyway. Now, at least on my system, this leaves us with an 45 amp Anderson power pole connector. Red and black. Red goes to the positive side. Black goes to the negative side. And in a real system, we would also have wired in the fuse, just in case. Now we'll go ahead and tighten those lugs down. And then we can take our lug caps, black for the negative side, red for the positive side. Now, remember I showed you, oops, that's my multimeter. Remember I showed you the voltage was very low. We can have a look at this again. There's our positive and there's our negative side. And our voltage can you see that? Our voltage is 3.17, something like that. Anyway, no matter. What I'm going to do now to activate the battery is connect it to a power source. So here is the solar panels on top of my camper caravan. We just want to touch the battery for a second with a live voltage source. This can be 12 to 15 volts or anyway, my solar panels have an open voltage of 22 volts. We're going to just touch it for a second, and that's going to wake up the battery. There's no charge controller or anything. Okay. I did it, and you saw how fast that was. Now, if I test again, let's bring my... So here is my plus. Actually, we can do it from up here on the lugs. There's my minus. Actually, there's my plus, and here's my minus. And now what's my multimeter say? Sorry, I'll get that out of the way. Let's try it one more time. And my multimeter says 13.17 volts. So now the battery is alive And we should be able to see this battery on our mobile phone. All right, let's try that. All right, guys, if you haven't done it already, we're going to need to get the app. Whoops. There we go. So, scan it with your mobile phone, Android or iOS, and your phone will take you directly to the Power Queen app on the store. Now, before you install that, make sure your Bluetooth is on. I'm trying to do this through the camera. Okay. Yep, that's fine. And we're also going to make sure our location services is on, because Google is evil and wants to know where you are and everything you do. So you've installed that app. Go ahead and click open. And what do we see here? We see the 24-volt battery, but that's not what we want. Let's see if we can find another one. There's a Power Queen, 12-volt, 100, Bluetooth enabled. We're going to go ahead and take that one. Failed to connect Bluetooth. Let's see if we can reconnect. Yes. Bluetooth connected. Let's see what it's going to do now. Check details. There's our battery. So let's go through and take a look at some of the features of this app. On the upper left side of the app, we have state of charge, SOC, state of charge. And at the moment, I'm at 52%. Next to that, we have standby. I don't know what else it might say if the battery is in a different state, but we'll come back to that another time. Under that, we have 23 degrees Celsius. I imagine that can be set to Fahrenheit as well. So that's the internal temperature of the battery. Under that, on the left, we have the amount of power coming in or going out. Next to that, in the center, we have the current. And next to that, we have 13.2 volts currently, the voltage of the battery. Now, one of the very cool things about this battery and this app is that we can actually check the state of the battery. Are the cells in good balance? Is the BMS okay? Are there any faults? We can check it with the app. Perhaps it'll be easier if I actually put a load on the system, or actually we can charge the system up so that you can see what happens when there's energy going into the battery. All right, guys, we're going to go ahead and plug in the power supply, the charger, actually. It's a 20 amp charger. It's probably a bit too much for this battery, but anyway, you'll be able to see the incoming charge and the change in voltage right here in the app. So here we go. So you see, we have 257.9 or 258 watts, 19.3 amps, and now our voltage has climbed to 13.4 volts. Oh, and there's a status here that says charging, and it needs 2 hours, 34 minutes remaining to charge. That's actually brilliant. We should also see the temperature start to rise shortly. Now, by the way, the charger I'm using for this is the Power Queen 20 amp lithium iron phosphate charger for 4S lithium iron phosphate batteries. We'll do a separate video about that on shore power. I think we'll do it for the camper caravan. Well, the temperature is remaining rather consistent. Of course, it's a short time, but that's absolutely brilliant. 256.4 watts, 19 amps, 13.5 volts now. Excellent. And I believe we've gone from 52% to 53% state of charge. Still hovering around that 256 watts. And a little bit lower now at 18.8 amps. Oh no, we've popped back up to 19 amps. Absolutely brilliant. By the way, for those of you who are ham radio operators watching this video, this charger is also RF quiet. So you can charge up your batteries with shore power without interfering with your radios. This was a nice feature, and actually Power Queen didn't realize how quiet it was. I suppose some engineer in the back room someplace knew exactly how quiet it was, but from the sales perspective, most people don't care about such things. All right, but anyway, we'll go ahead and stop it now. Hold on a moment. Okay, the charger is off. We've dropped down to 0 watts, 0 amps, and 13.4 volts. All right, guys, now I think it's time to put a load on the battery. And this is what I'm using. I've got my Microsoft Surface, my infamous Microsoft Surface, and I've got the ICOM IC705. I'm going to plug in the battery into that power distribution block. So that the entire station is being powered from that battery. I'll need to put the phone down to do it, but give me a second, guys. So here's the whole station. Again, there's the Microsoft Surface. There's the ICOM IC705. The Surface is being charged. I think you can see the little charging light. The Surface is being charged from the 12.8 volt battery. The ICOM IC705 is also being powered by the 12.8 volt 100 amp hour battery, and it's all going through the WindCamp power distribution board there. So let's go ahead and start the app and see what type of load we're putting on the system. Outstanding. So even without connecting, we can see the status of the 12 volt battery, which is the top one here at 53%. And this is actually quite interesting, there's the 24 volt battery as well, which is it's in a different building from where I am right now. And I find it interesting that I can see that battery in the app from where I'm at. But that's absolutely okay. Let's go ahead and click on the 12-volt battery and see what type of load we're putting on the system. Outstanding. So we're still at 53%. The system is on standby. Even though we're putting on about, oh, there we go. Now it's measuring the load. So we have about 22.9 watts, 1.7 amps. And that's because we're charging the Microsoft Surface. It's been sitting here unpowered for a couple of days. We've had thunderstorms, so I haven't been able to keep anything connected. So we have the Microsoft Surface, we have the ICOM IC705, we have the charger for the Microsoft Surface, and of course the 705 is being powered. This is absolutely brilliant. So what can we see? We can see the state of charge on the top left. We can see the, what does it say? Discharging. Okay. It says it'll last for 37 hours and 41 minutes. That's brilliant. The temperature of the battery is a little bit lower now, 21 degrees. That's excellent. We can see the power load. It's jumping between 16 and 22 watts. That's about fine. That's absolutely okay. We've got current, 1.2 amps, sorry, minus 1.2 amps. And the current voltage is 13.1. Let's look at the balance. What does it say about the balance? All cells are well balanced. Okay, let's look at this. Probably they should have a better word than cells for this center one, but let's click it. Battery is in optimal working condition. That's magnificent. Now let's go ahead and click BMS. Your BMS is running smoothly, and I imagine it absolutely is. Otherwise, we wouldn't be able to connect to the battery with this app. What do you guys think they should call this? Cells? I think cells isn't a good word. Battery status, battery something, but not cells. Anyway, no matter. Okay, some of the other things in the app. Device name, and I believe we can even edit that name, but I won't do it now. There's the serial number of the battery. There's the cyclic life, or cycle times. That's the number of times it's been fully cycled during a charge cycle. Then we have the firmware version, and I imagine we can go to the button here and stop that. On the next page, we have troubleshooting, unable to connect devices, but I've shown you why you wouldn't be able to connect. And this is some useful information for getting the battery connected. And what do we have over here? Over here we have, again, discharge switch. We can turn it on, turn it off. We can remove the device from the app. We can power off the device or put the device in that sleep mode again. So absolutely brilliant. Very simple app, very easy to use, not so complex as the Victron app, but also it doesn't have all the features of that Victron app, but that's okay. I'm wondering, with a cheap Android device, maybe this is all I need. It's giving me a lot of information. It tells me how much power is coming in. It tells me how much power I'm using. It tells me how much time I have left before the battery is full or the battery is depleted. So, not bad. It tells me the temperature of the battery, and it gives me indications if the battery is not okay. So, this is absolutely brilliant. Look, guys, if you're watching this on the 20th of July, I believe it is, you still have a chance to get one of these batteries at an incredible discount through the Amazon Prime Day sale that Power Queen is participating in. If you're watching afterwards, please use the links I leave in the description because you can still get some discount using my discount code for Power Queen, Julian, OH8STN. And you can support the channel at the same time. It doesn't cost you anything. It's just a cooperation for us to support Power Queen and for Power Queen to support the channel. So it's a win-win all the way around. All right, guys. I hope this video has been informative. And if you have any feedback, please leave it in the comments. The only thing I ask is that you be polite. Most of you usually are, so it's not really an issue. Alright guys, if you like what I'm doing, if you like the content I'm creating, please let me know by leaving me a comment, a thumbs up, or even a super thanks to let me know. And if it's not too much to ask, please share this video with someone or somewhere where other operators might enjoy it. Rock and roll, guys. You are all absolutely magnificent. Thanks for watching. Ciao.